So you saw that with hinted handoff, it's automatic. Blocking read repairs, both flavor is automatic. So we needed something which would guarantee, because not every time the automatic process will guarantee that the data has been updated. So these are the general rules, right? When you would want to run your node tool repair. And the top reason is recovering from a failed node and bringing down a node, bringing up a down node beyond the hinted handoff period. And that periodically on nodes where the data is infrequently read. We now know the reasons why. But we still don't know exactly why delete activities can cause a problem. But let's just take it for granted that yes, if there are deletes, node tool repair becomes very, very important. Now the question is, I'm going to leave this slide on for now, that how do I compare the data? And remember, this is a NoSQL, and we are basically talking about perhaps the best practice of storing up to a terabyte of data on a given node. If I were to have replication factor 3, and if I have terabytes of data, then naturally the whole comparison is going to be fairly, I would say, time consuming, resource consuming. Is there a way to optimize that? I cannot go brute force, so I can't read a terabyte of data on disk 1 on node 1 and a terabyte of data on disk 1 on node 2 and start comparing byte by byte by byte. That's not going to be efficient by any stretch of the imagination. So what can we do? So this is exactly where, right, a concept of Merkle tree, right, comes in. Right, so the notion of Merkle tree, obviously created by Dr. Merkle, and this is the Wikipedia example of or explanation of Merkle tree. What it basically states is, I want to read the disk blocks, right, from a particular node and create a hash out of that. And then what I can do is I can take multiple hashes and create a hash of that, kind of like a composite hash. And then I can create yet another hash from that until I reach the top. So effectively what will happen is, over a period of time, right, this is going to happen. So I have multiple range of tokens at the grassroots level, at the bottom level, that I read from. You can see the token ranges, let's say 0 to 32 on the left, right, 32 to 64, 64 to 96. Like this, I keep reading and I make hashes out of it, and then I can make a gigantic hash out of that. If this is created on a per node basis, and if only the Merkle tree, which is basically the nodes represented in dark blue, this is only nothing but a bunch of hashes, it's going to be far smaller than 1 terabyte of data or more. If I can transmit this Merkle tree, and if 2 Merkle trees are obtained, can I not simply check the root hash? If the 2 Merkle trees from 2 different nodes or 3 Merkle trees from 3 different nodes, the replica nodes, are with me, who am I? I am the repair coordinator on which the the repair job is actually running. Then can I not compare the root node? If the root node matches, then I know for a fact the data is identical. If the root node is not matching, then can I traverse this tree and figure out which are the nodes that are not matching? So I know for a fact that this root node is not matching because this node is not matching, this one is fine. So if this one is fine, I know this part of the data is good. If this node is not, this hash is not matching with the other equivalent Merkle tree, then I know it's either this or this, or it could be both of them. It just turns out that this hash is not matching with the other replica node because both of these nodes are not, these hashes are not matching. And both of these hashes are not matching because of this block and this block. Once I narrow it down, among all of this data, I now have to focus only on transmitting this data and this data. the process of patching still remains the same as that of read repair. At the end of the day, Cassandra has no other way to determine whether the data is recent, whether the data is to be kept versus ignored, other than the timestamp. The whole idea of this Merkle tree is to narrow down as quickly and as efficiently as possible to the data set which is the question mark in terms of why it is not matching. So effectively what will end up happening is this is what will end up happening. Two Merkle trees side by side, and you know that this is what caused the mismatch. So you're going to exchange the data and you're going to either add the data or update the data in the replica nodes. So that's basically the whole idea, right? And this is a manual process. Needless to say that when you're creating a Merkle tree, despite of all of its efficiencies, the process to create that tree can be fairly intense. You are going to crunch a large amount of data on a given node. You are going to use higher memory. So needless to say that if this is a manual activity, something that I have to run once a week, once in 7 days, for now we are going with that number, 7 days, you have to ensure that you find a time slot that allows the Cassandra cluster to have enough extra bandwidth to take on this additional work. You really wouldn't want to run a nodetool repair process during peak business hours. It's only going to overwhelm the cluster, perhaps to a point of failure. So you can counter argue and say that, okay, I am a global enterprise. I really do not have any, window of downtime or lean period. So in that case, what you'll have to do is you need to make sure that your Cassandra cluster has enough surplus capacity provisioned to ensure that it can also absorb the additional workload introduced by the repair process. In other words, you may want to have bigger machines. In other words, you may want to have disk storage which is really fast. You may want to have enough surplus disk storage left, because obviously on many occasions Merkle tree will be stored on the disk. Maybe there will be some data transfer, there will be some additional data that will be stored. So the whole idea is, if you have the surplus capacity, then you can have a model whereby the cluster is able to absorb this additional data transfer, additional data compute. Now the question is, how do you arrive at that? What is additional? Additional is a very subjective word. So this is something that you will have to potentially, work backward from experience, from the use case, from the usage pattern, and the amount of data that you are basically storing, and more importantly, how efficiently you are managing the cluster. If your cluster very often gets overwhelmed, suffers from outages, network is not necessarily reliable, your infrastructure is not necessarily reliable, in those circumstances, right, you will find yourself in a situation where you will be required to run these processes often, and that can cause problems. So it's, I think, a matter of observing the cluster, to a point where you are really you really are on top of all the operating data, and based on that, you need to basically figure out what the cluster size is going to be. So it's not just your usage from an application perspective, but also from an operations perspective. So that's about nodetool repair. It's a manual process, needs to be scheduled to make sure that at some point in time your replicas are looking alike.